All right, this is logarithmic and exponential equations. This is a review of how to solve equations that are logarithmic or exponential equations that need logarithms. And so practice is what makes perfect, right? This is what's going to make you stronger. The best way to practice this always is for you to do it first and then press play to see if you did it correctly. All right, we have a logarithm equaling another logarithm. They both have the same base. We just take what's inside and make it equal to each other. Add x, subtract 13, and divide. Now, the answer here is -5, which is concerning because you can't have a negative number inside a logarithm. But a negative times a negative actually makes this a positive number, and -5 plus 13 is a positive number, so that's a good solution. Number 2. For this one, I need to write as one logarithm to begin with. And because we're adding, we're going to multiply them together to begin with. So there's that step. The next step is, now that we have one logarithm on the left and one logarithm on the right, we make them equal to each other. I'm going to FOIL this right away. That's n squared minus n plus 3n. And then minus 3. I'm going to combine like terms. So I notice the n squares actually eliminate. So I'm not going to make it equal to 0. I'm just going to combine like terms. So I'm going to add 3. 3 take away 1 is 2. Divide by 2. Now, make sure that's a good solution. So if you plug 8 in, all the logarithms are positive inside, and it's great. Number 3. ln is a natural logarithm. The base is e that you don't see. So the 2 will become exponent inside. That's a power property. 1/4 again becomes the exponent inside. When you're adding, it means you're multiplying these together. So I'm going to do that. And now it's written as one logarithm. So understand the different properties, how you can write them as one logarithm. Now that we have one logarithm equaling another logarithm, they have the same base, then we can make them equal to each other. So a plus 3 squared. Now, the 4th root of 16 is 2. So that becomes 2 times a plus 7. We're going to FOIL. That's a squared. That is 3a and another 3a and 9. That's 2a plus 14. And then I'm going to combine like term. Now, this is quadratic, so we're going to make it equal to 0. So we have 6a, but if I subtract 2, it becomes 4a. And we subtract 14, that's minus 5. That is factorable. That's plus 5 and minus 1. So the first factor is -5. The next one is positive 1. The -5 plus 7 is a positive number, but -5 plus 3, that's a negative number inside a logarithm. Bad. So the only correct answer is 1. On to number 4. I should have my answer key here beside me just to double check. Number 4. Of course, that one was done correctly. I need to write this as one logarithm. So subtracting means I am going to divide. Once I have one logarithm on the left and one logarithm on the right, then I can take what's inside the logarithms and make them equal to each other. Next, I'm going to multiply both sides by c subtract 6. Now, when you have c plus 6, c take away 6, that's called the difference of squares. So that's c squared subtract 36 when you multiply it out. Now it's a quadratic. So I want to keep the quadratic positive, but I want it equal to 0. So we have c squared. I'm going to subtract 3c, and then when I subtract 4, it'll be -40. I'm going to factor it. That's -8 and 5. So one solution is 8. The other solution is -5. Be careful that they both are good. Notice the -5 take away 6. That gives you a negative number inside, so I'm going to cross it out. Positive 8 is good across the board, and there's one solution. This is called an extraneous solution, and we cross it out. Number 5. Here's the other type of logarithmic situation where it's equal to a number. So I'm going to isolate the logarithm. I'm going to add 9 to the other side. So that's equal to 7 when you add 9. Then I'm going to write it as an exponential. So if you have a logarithm equaling a number, write it exponentially. That's 5v plus 23. The base is 7. The base is 2 to the exponent 7. 2 to the exponent 7 is 128. Subtract 23. That's 105. Divide by 5. That's 21. And 21 is a great answer. Done. Number 6. All right, write this as one logarithm by dividing. So the property is if you're subtracting and the bases are the same, you divide. There it is. Now it's just equal to a number on the other side. So we're going to write this exponentially. So inside the logarithm, equal to the base to the exponent 1/2. 16 to the 1/2 means the square root of 16. That's 4. Multiply both sides by p, subtract 2. Make sure you distribute. And then we combine like terms. So 4 subtract 1 is 3. Add 8, and that's 13. And then when you divide, you get a fraction, which is 13 over 3. And that gives you a positive number inside the logarithm. So it's a great answer. Number 7. Ln has a base of e. So you have ln r plus 1. Now, this 3 can actually belong as an exponent inside. So that's one property. The other property is when you're multiplying and you're adding, you can multiply them together. So there's the two properties together. So the 3 becomes an exponent. When you add, you multiply it together. Now, 2 to the exponent 3 is 8. Remember that. So this is r plus 1 times 8. The base you don't see is e. That's to the exponent 7. Different ways you can do this. You can actually divide by 8 right now if you want, and not distribute, and then subtract 1 to get your answer. So this is the answer. If you want to use your calculator, you can. So let's see, what would it look like if you put that in Desmos? Oops, let me show you. So in Desmos, you could just say e, and to the exponent, let me move my face. There it is. I just need the exponent button. So e to the 7 divided by 8. Move the cursor first. Then divided by 8. Move the cursor and subtract 1. So it's about 136.079. There it is. All right, number 8. So do you know your properties? So that 1/3 goes as an exponent for 64. That 7, that 2, becomes an exponent for n. If they're adding, you're going to multiply them together. Now the cube root of 64, what number? 3 times itself is 64. That number is 4. So this is really 4 times n squared. Now I could write this exponentially. So when you're adding, you multiply them together. Exponentially, it would be 4n squared is equal to 9 to the exponent 2. 9 to the exponent 2 is 81. Divide by 4. So you have 81 divided by 4. When you take the square root, that would be 9 over 2, and it's positive or negative. Now, the negative is not going to work, because if I have a negative number inside the logarithm, it's no good. So it's only positive 9 over 2. The negative 9 over 2 is extraneous. Turn the page. These are exponential equations where you may or may not need logarithms. You could always use logarithms, but if you don't have to, you don't have to. So for this one, I can make the base the same. 27 is 3 to the exponent negative 3. And there's a 2x subtract 6 in the exponent. 9 is 3 squared, and there's an x minus 1 there. Once the bases are the same, just make the exponents equal to each other. And I'm distributing as I am going. So to get rid of the parentheses, multiply it. And now combine like terms and solve it. So I'm going to add 6. I'm going to add 2. I'm going to divide. So 20 over 8 could also be written as what? 4 goes in both, right? 5 over 2. 2.5. Done. And for an exponential equation, it's all real numbers. You can have a negative, a positive, or 0. 10. Can I make the bases the same? Yes, you can. The base is 2. So that's 3m plus 1. 1 over 8 is 2 to the negative 3. That's m plus 4. Sometimes it's hard for me to see. And then 32 is 2 to the 5. And that exponent is m subtract 2. All right. So there's the setup. All the bases are the same. When you are multiplying, you add the exponent. So this becomes 6m plus 2. And you're going to add these together. So that's negative 3m plus 5m. That's 2m. That's negative 12 plus negative 10. Can you do that? So negative 12 plus negative 10. There it is. And then combine like terms. So subtract 2. Subtract 2. Divide. And it's okay that that answer is negative 6. All right, number 11. I cannot make common bases. So now what do? Is I have to write them as a logarithm. So take it and write this logarithmically. So that's w subtract 1. And the logarithm has a base of 5 and 90. Add 1 to both sides. And now use your calculator. So I'm just going to type in log, 90 divided by log 5. And then add 1. And you get 3.796. All right, let's try that again. Number 12. I want to isolate the exponential. So it's e, and I think it's 3r subtract 2. I'm going to add 16 to get to the other side. That's 136. To solve this, we're going to write it as a logarithm. So the exponent is 3r subtract 2. The logarithm with the base of e is ln, and then 136 goes inside that. To get r by itself, we're going to add 2. And then we're going to divide by 3. So that's what we're going to put in our calculator. Ln 136 plus 2 divided by 3. This is what it looks like. So start with this. And then ln 136 plus 2. And then in the denominator 3. And you get 2.3042. I'll just do it to 3 decimal places. So 2.304. Number 13. Keep practicing with me here. Can you solve this exponential equation? So identify it, first of all. So how do I undo what's around it? So subtract 14. So that 2k plus 5. My eyesight's going. So subtract 14 is negative 8. Then divide by negative 4. Now it's important, if you divide and you end up with an exponential equaling a negative number, no way. Cross it out, no solution. But this is good. A negative divided by negative is positive. Write this as a logarithm. The exponent, the logarithm has a base of 9 and 2. To get k by itself, we're going to subtract 5. And then we're going to divide everything by 2. So that's what you're going to put in your calculator. So start with the divide sign. In the numerator, you're going to go log 2 divided by log 9. and then move the cursor, subtract 5, and then in the denominator 2. So that's negative, and it's okay, the answer is negative. Negative 2.34. Negative 2.342. And there's your answer for K. All right, identify the exponential and then isolate it. So add 9. And to undo a fraction, you do the reciprocal. That's m subtract 8. Make sure I got that. So the reciprocal is 3 over 2. So do the reciprocal to both sides. This is 15 times 3, or 90 divided by 2. However you want to look at it, it's 45. There are no common bases here, so write it as a logarithm. And then add 8 and use your calculator. So that's log 45 divided by log 5. Move the cursor, plus 8. All right, now the most complicated questions. Oops, plus 8. That's 10.3652. So 10.365 using your calculator. All right, now the most complicated part is when you have exponents on both sides. So we just have to work through it to do the algebra necessary to get x by itself. So on the left side, I have the exponent 4x plus 1. I'm going to write a logarithm with a base of 3, and then the other side will go inside the logarithm, which is 8 to the exponent x subtract 5. Next, we're going to do the power property, which means x subtract 5 will be a product in front of the logarithm. That's what you can do. So if you have an exponent, it can be written as a product. We're going to expand here. We're going to distribute the logarithm to both. You just put them beside each other when you expand. Next, we're going to gather all the x's together. So to do that, we're going to subtract x log 8 base 3. And we're also going to add, actually we're going to subtract 1 to the other side. The last step is we're going to factor out an x and divide. And then use your calculator. All right, that's what we're going to put in the calculator. So start with divide sign, and then it's negative 5. It's log 8 divided by log 3. Move the cursor, subtract 1. And then in the denominator, it's 4 subtract log 8 divided by log 3. And there's your answer. Okay, one more left to do. So it's negative 4.966. So negative 4.966. All right, let's do it. Last one for the lesson. Again, the bases cannot be made the same. They are both like equally complicated, but I'm going to take 15, subtract 2x. Either direction will give you the right answer. So take one of the exponents and then write it as a logarithm. So the base is 7, and what goes inside the logarithm is 4 to the exponent 2x plus 3, right? Yeah. Next, the property is 2x plus 3 can be written as a product in front of the logarithm. And now we're going to distribute. So that logarithm gets distributed to both. So you just put them beside each other. Don't make it complicated. Now we're going to gather the x's together. So that means I'm going to subtract, what is that, 2x log and I'm going to subtract 15 to the other side. I'm going to factor out an x and divide. So this is what I'm going to put in the calculator, this over here on the right. So that's what I put in the calculator. Let me show you. And then we're done. So start with the divide sign. And then it's 3 log 4 divided by log 7. Oops, wrong one. Move the cursor, subtract 15. In the denominator is -2 and another -2 log 4 divided by log 7. And that's it. And you get 3.756. And your lesson is done. So there it is, 3.756. So there's your review on solving equations. Logarithmic equations, exponential equations, using logarithms, using common bases. Now there's some homework to go with it as well. Mr. G Math, over and out. Till next time.